Hello and welcome to another one of these ADD videos. Today we're going to be looking at an example of completing the square. Just a quick recap, when would we complete the square? Anytime. So you could be asked to go from this general form to the standard form of a quadratic function where h comma k is the vertex. You might be asked to find the x-intercepts. If you set y equal to 0, you can complete the square and then subtract the k over, divide by a, square root both sides, plus or minus, all that good stuff. Okay. I will solve the intermediate video for intercepts. The beginner video will be for the standard form. What are the steps? Well, first, remember that you got to make sure the coefficient of x squared is 1. After you do that, if not, you're going to factor out. If it isn't a 1, what you're going to do is you're going to factor out whatever's in front of the x squared, your a. If that's not a 1, pull it out of just the first two terms. Leave a little space for the plus c, and we'll deal with that later when we see the advanced video. But take half of b and square it, and this is going to create what's called a perfect trinomial square, which then can be factored into a binomial squared. Now, because we added a term, we need to balance it. So whatever we introduce, we need to subtract or add, do the opposite of to balance it. Okay, and that's if we're doing it for the standard form. I'll show you both methods later. It's easier if you just watch this in action. Okay, so this is talking about whether are we trying to find the x-intercepts or are we trying to find the standard form. So if it's in standard form, we're trying to get to this thing here. There's a y on this side, so it makes no sense to add or subtract a number to this side. So what we have to do is the opposite on. We have to do the opposite to c here. So whatever b over 2 squared is, we're going to either subtract that or add it depending on what the sign is inside. So whenever we're trying to find it in standard form, whatever is added to your first two terms or subtracted needs to be done opposite on the same side. But if we're finding intercepts and you subtracted that c over, then you're going to do whatever you do to one side, you do it to the other side. That's what the bottom line means. So this one's for your x-intercepts, this one's if you're going to standard form. All right? So recap, make sure it's 1. If not, factor out half of b squared, do the opposite over here. All right, so let's see it in action with this example here. Coefficient is a 1. We're good to go there. So then what we do is we rewrite the expression. All right, so what I did here, all I did here was just rewrite the expression, gave it a little space for the term that I'm going to introduce here. All right, so now what we do is we take half of -5 and we square it, and we get a plus 25 there, and it's going to go right next to that minus 10x. And what we've done is we've created what's called a perfect trinomial square. All right, that's going to have a little significance here when we're trying to factor that expression down. So we'll come back to that here in a second. We just introduced a brand new 25. We have to balance that 25 by subtracting 25. All right, so we know that we have a perfect trinomial square there. So we know we have a perfect trinomial square for these three terms. What's important about that? Well, what's important is that we can factor it into a binomial squared. All right, and so this perfect trinomial square ends up being this binomial squared. How did we get that? Well, the first expression is always the square root of the first term. So x is the square root of the x squared. And then this minus 5 will always be whatever number you get when you took half of -10. Notice I didn't write the x, just half of b. And then you put a squared, and then this -36 came from these two here. So let's say this was a intercept problem. Real quick, the vertex here would be 5, -36. Let's say it was an intercept problem. You would set y equal to 0 for the x-intercept. The y-intercept is pretty easy. You just set that equal to 0. You'll get -5 squared is 25, minus 36 is -11. Or you could have set both of these equal to 0, and that would be your y-intercept. But if we are looking for our x-intercept, we set y equal to 0. It's always the opposite for intercepts. And when we're doing so, what ends up happening is we add the 36 to both sides. And we get 36 equals x minus 5 squared. And then we square root both sides. Don't forget the plus or minus on the side that you take the square root of the number. And then we know the square root of 36 is 6. So then we add 5 to both sides. And when we do so, we get 5 plus or minus 6 is x. So we get 11, 0. And 5 minus 6 is -1, 0 are your x-intercepts. So you can see that there's applications to this. You might also see it in trying to find the equation of a circle in its standard form. All right. Keep an eye out for the rules. Again, recap. Make sure that this is a 1 right here in front. Okay. If it's not, we're gonna have to factor out whatever our a term is of just the first two terms. But in this case, it was a 1, so we took half of b and we squared it, got this 25. And once we got the 25 added there, we had to subtract it to keep it balanced. Okay. I will do the next intermediate problem as an intercept first, and you'll see how it works whenever I'm completing the square. You'll see that this minus 25, when we have it on this side, will be actually a plus 25. Right. We do the same thing if it's a numerical value on this side. And that's also what you would get if you moved this -25 over. So it's actually doing the same thing. Don't get too bogged down in the details. I hope I've cleared up enough doubts for you to practice these problems. As always, practice, practice, practice is the key to understanding this stuff. Completing that square is intimidating maybe at first, but if you practice a little bit, you'll see it's not that bad. All right, just like any other topic in math. Thanks for watching. Have a great day.